is PreCalculus 12, Chapter 7.1. We're going to be looking at solving trigonometric equations graphically. And unless there's an interval given, then there are an infinite number of solutions. A new thing you need to learn is principal solution. And that requires to give us answers between 0 and the period. Okay, and general solutions follow this as well. So the reason why we have principal solution, it's related to the principal angle. And we were told that the principal angle goes from 0 to 2 pi. However, we have transformations now. And because the transforms modify the period, we need the principal solution to go between 0 and that period. Because all other answers are just adding the period to the principal solution. And when we're doing this, please make sure that your calculator is in the correct mode, radians or degrees. And if there's no degree mark, it must be radians. If it has a degree mark, then use degrees. And remember, when you're answering in degrees, you have to use the units, which is the degree mark. Now, just like in quadratics, there is a possibility that no solutions exist. And the hardest part of this, finding solution, is figuring out the number of solutions, whether it's general or principal. You should be able to look at the graph to tell. Okay, you just look for the pattern. Once you see a cycle, you just count the number of solutions within that cycle, that first cycle. Okay, let's do an example. Solve 2 cos squared x equals 1 to the nearest tenth of a degree. We have up to 4 solutions, general and principal. Because we have degree 2 and 2 solutions for cosine. Well, up to 2 solutions for cosine. Okay, so on our calculator, we're going to enter this. So we move the 1 over to the other side, we get -1, and we're looking for zeros. And if we graph this, we see we get 1, 2, 3, 4 answers. And solving for it, we would get 45 degrees, 135 degrees, 225 degrees, 315 degrees. We take the difference of these, and it's 90 degrees. And if we look at the graph, we also see that the pattern is right on the center line. So we have one solution, one general solution. And we have 45 degrees plus 90 degrees n. N is an integer. This is normally the period. And one thing you might want to look at here is we have 90 degrees for our x scale. And if we look at our graph, this is 90 degrees, this is 90 degrees, 90 degrees, 90 degrees. So it just makes it easier to tell what quadrant our answers are in when we use 90 if we're in degree mode. And our period is 360 degrees. So our principal solutions are all four. 45 degrees, 135 degrees, 225 degrees, 315 degrees. And this is our general solution. Okay, let's look at the next example. We have this to solve. 16 equals 6 cos pi over 6x plus 14. We want to solve to the nearest hundredth. We have up to two solutions because this is a degree 1 trigonometric function. And to solve, we just go 0 equals 6 cos pi over 6x. We have minus 16 coming over to this side, so 14 minus 16 is negative 2. This time we're in radians, so we want to change our window a bit. I've already graphed it for you. x1 is negative 2.35. x2 is 2.35. x3 is 9.65. If we calculate the differences, we get 4.7 and we get 7.3. So we have two general solutions. And we look at x1 and x3, it's both coming up, up. So either one could be our general solution, but we want to use the principal solution. So these two are our principal solutions. If we look at our period, we have 2 pi over b. This is 2 pi over 6. This is 2 pi times 6 over pi. The pi's cancel out and we get 12. So our principal solutions should be from 0 to 12. This is 0 to 12. You could calculate your period by doing x3 minus x1, but this could produce rounding errors. It doesn't in this case, but it could. And our general solutions, we have 2.35 plus 12n, and we have 9.65 plus 12n, n element z integers. So we always have period times n. Let's look at another problem. 4 sine squared x equals negative 1. Solve to the nearest hundredth radian. We have up to 4 solutions because we have a degree 2 trigonometric function, and it's sine, so sine can have up to 2 solutions. We plot this. We're going to plot 4 sine squared x plus 1 equals 0. And we look at the graph. We see this is the max. We see this is the min. The min is above 0, so there's no solutions. Because 4 sine squared x plus 1 is always positive. That means it's greater than 0, not greater than or equal to 0. Okay, so when you're solving graphically, make sure you adjust your window to see 2 cycles. This is twice the period for the domain. Use the amplitude and center line to calculate the min and the max for the range. Make sure the window is set properly for degrees or radians, and it's easier to look for zeros than intersections. And that completes this lesson.